Okay, good day everyone. Welcome to Marinais Powerhouse Team Review and Training Center. So we're just going to continue our lecture regarding AC circuit single phase system. No? And today, we are going to discuss the AC circuit objective type because we are already finished with the calculations. No? So punta naman tayo sa mga terminologies. No? Let's go with the different terms. No? By answering our multiple choice questions. Okay. Number 28. The AC system is preferred to the DC system because letter A, DC voltage cannot be used for domestic appliances. Letter B, DC motors do not have speed control. Letter C, AC voltages can be easily changed in magnitude. Letter D, high voltage AC transmission is less efficient. Okay? AC system is more preferred than DC because of this advantage. No? AC voltage can be easily changed its magnitude. No? We can step up, step down the voltage. No? The problem with DC, actually this is a long story of the two electrical scientists, the Nikola Tesla and who is that? The inventor of incandescent bulb, Thomas Edison. No? I watched a film of Nikola Tesla, in the YouTube. You can watch it, the life of Nikola Tesla. Don't you know that Nikola Tesla has one of the greatest contribution, in terms of electricity, even in electronics and communication engineering field, even in mechanical, Nikola Tesla has one of the greatest contribution because of this AC system, Siya ang inventor or he's the one who developed the AC systems, before DC systems, It's a long story, kukukwento natin 'yon. So, panoorin niyo na lang yung ni Nikola Tesla, yung buhay niya. Okay? So, DC system has a very large voltage drop, power losses in the line. If you have AC system, you can reduce the line losses, because you can easily change its magnitude, because of the transformer. Okay? Which of the following is not true about AC? Develops eddy current. It can be transformed. Is suitable for charging batteries. Interferes with communication lines. Letter C is the answer. It's not true, suitable for charging battery. Well, of course, you need a rectifier, If you're going to use AC, you need a rectifier so that you can charge a battery, But not directly AC. Okay? 30. 60 cycle travels 180 degrees in how many seconds, by the way, I think this is a basic computation. I have to show this. Okay, so we have a 60 cycle. I'll just get one cycle, complete set of positive and negative values. Okay? So this is our period T, 1 over frequency, right? 60 cycle frequency travels 180 degrees. So this is 360 degrees, right? Okay? 1/2 of it is 180 degrees. Question, how many seconds? For 360 degrees, you have 1 over the frequency, right? But for the half, 180 degrees, of course, you have to divide it by 2. This period T must be divided by 2. Because 180 is half of a cycle. So, we have 1 over frequency 60, then divide it by 2. So, therefore, the T over 2 simply T over 120 degrees. So, that is 120 degrees. That's why letter B is the answer. RMS value of sinusoidally varying current is more than that of the average. Again, because RMS is 70.7% of the maximum, the average is 63.7% of the maximum value. Impedance of an AC circuit is what is the impedance? A vector quantity. It's a vector quantity. Meaning it has an angle, it has a direction. In the impedance triangle, the inductive reactance and the impedance peso are analogous to, or just the same with inductive voltage and the total voltage. No? 34. The current will lag the voltage when lagging current, of course, that should be inductance is present in the circuit. If that is inductive. Leading, if that is capacitive. The current will lead the voltage when? O, yun na nga. Nakasagot lang natin. Capacitive reactance exceeds or greater than the inductive reactance. By the way, so, if that is X sub C greater than X sub L, that should be your X sub C minus X sub L. Then what do you call this? The difference of the two reactances. That is what we call the net reactance. Yan, pahabol na lang natin to. Net reactance. If we mean net reactance, the difference between the two reactances. Okay? On the left side, that is reactance that has a greater value. And this has a lower value. No? For voltage and current to be in phase. So, if they are in phase, should be both A and B. The circuit impedance has only resistance. Okay, that is in phase. The voltage and current appear at the zero and peak values at the same time. No? So, if we mean at zero, no? So, if this is our voltage waveform, okay, this is our current waveform. There is no phase difference between them. The theta here is zero because they have the same starting point. No? Okay, 37. If the resistance in series RC circuit is increased, the magnitude of the phase angle, what will happen, no? If you increase the resistance in series RC, what will happen? It decreases. No? Tama ba yun? So, okay, in RC, let's say this is our R. Let's say this is our X sub C, right? Negative J X sub C. Okay? You see? So, this is the impedance. That is your ZRC. If the resistance is increased, so you increase this resistance. Okay? The magnitude of the phase angle, what will happen? Take a look here. This will happen. You see? The angle, the new angle decreases. Right? That's the answer. Letter C. No? Decreases. Number 38. In an AC circuit, a value of watts divided by the value of volt ampere. So, meaning this is P over S. No? Which of the following indicates close to unity? High power factor. If we mean a high power factor only ranges from 0 to 1. No? Okay? So, if you have a higher power factor, you are more nearer to 1. No? To unity power factor. 39. Reactance will cause the current in a circuit to vary only when? Reactance will cause current in the circuit to vary only when AC current flows. Okay, if you have your X sub L and X sub C, that is only present in AC circuits, no? So, not in DC. 40. Power absorbed in a pure inductive circuit is 0 because I've said before that only resistive elements consumes watts, no? R lang ang nagko-consume ng watts, no? Power absorbed in a pure inductive circuit is 0 because power factor of the circuit is 0. No? In pure inductive, no? Okay? So that is 0. Power factor of the circuit is 0 in pure inductive circuits. One of the reasons for improving the power factor is to avoid the voltage regulation constant, no? To avoid poor voltage regulation. Well, we have a detailed discussion about power factor correction. No? At series resonance, the circuit power factor is always unity. If we mean resonant, the circuit is resonating, the power factor becomes unity of that particular circuit. Well, that is the end of AC circuit single phase, mga kawerpa. So maraming salamat po sa pag-attending nyo sa ating pong pre-electrical engineering review. No? So until then, no, we'll see you on the next lecture. Thank you and God bless you all.